Have you ever wondered how your favorite robot, say a Mars rover or a household Roomba, is designed and built? Well, let's unravel this fascinating process where we dive into the intricate web of mechatronics. Picture this. Mechatronics is like a grand symphony, where different disciplines of engineering perform in perfect harmony to create something truly extraordinary. Mechatronics, for the uninitiated, is an interdisciplinary field that combines mechanical engineering, electronics, and computer science to create intelligent systems. Our beloved robots. But how do these different domains intertwine? Here's a relatable analogy to simplify this concept. Imagine a robot as a human body. The mechanics of the robot, with all its gears, levers, and motors, are akin to the bones and muscles in our body. They provide structure, movement, and strength. Without them, neither the robot nor we would be able to move or perform any physical tasks. On the other hand, the electronics in a robot can be compared to the nervous system in our bodies. Just as our nervous system transmits signals to different parts of our body, the electronics in a robot transmit information and power to its various components. And finally, the computer in a robot is like our brain. It's the command center, the decision maker. It processes all the information received from the sensors, just like our brain processes the information received from our sensory organs, and then makes decisions accordingly. So you see, a robot isn't just a heap of metal and wires. It's a meticulously designed system where mechanics, electronics, and computer science collaborate harmoniously to perform tasks, solve problems, and in some cases, even mimic human behavior. As we delve deeper into this fascinating world of mechatronics, remember, just like a human body, a robot is a harmonious collaboration of various elements. And it's this intricate web of mechatronics that enables us to create these marvels of modern technology. Imagine creating a skeleton and muscles for a robot, just as nature has done for us. In the world of robotics, mechanics play the role of the bones and muscles, forming the structure and enabling movement. It's a fascinating process, much like building a complex Lego structure, where each piece has a purpose and contributes to the overall functionality. Consider the skeleton, our body's support framework. It's sturdy yet flexible, allowing us to perform a vast array of movements. Similarly, a robot's structure, typically made of materials like steel and aluminum, provides stability and shape. This structure, often referred to as the robot's chassis, is meticulously designed to endure loads, resist wear and tear, and accommodate the robot's components, much like our skeleton houses our vital organs. Now let's talk about muscles. They're the driving force behind our every motion, from blinking our eyes to running a marathon. Muscles contract and relax, pulling on our bones to enable movement. In the realm of robotics, this muscular role is played by actuators. These devices convert various forms of energy, such as electrical or hydraulic, into physical motion. Think of them as the robot's muscles, flexing and relaxing to create movement. But how do these muscles know when and how to move? That's where controllers come in, functioning as the robot's nervous system, sending signals to the actuators, commanding them to move. It's akin to how our brain sends signals through our nerves to our muscles, instructing them to contract or relax. So, in essence, the mechanics of a robot, its structure and mobility, mirror the functions of our bones and muscles. They provide the robot with form and the ability to interact with its environment. It's a delicate balance of design, material choice, and engineering prowess, all working harmoniously to create a functional and efficient robotic system. The mechanical design of a robot is its backbone, providing structure and movement, just as our bones and muscles do for us. And just as our bones and muscles are crucial to our everyday activities, so too are the mechanics in the world of robotics. Now that our robot has a skeleton and muscles, we need to give it a nervous system. This is where the magic of electronics comes into play, serving as the conduit of communication between various parts of our machine, just as the nervous system does in our bodies. Let's start with sensors. Much like our senses, sensors are the robot's way of feeling the world around it. They gather data about the environment, whether it's light, sound, temperature, or even the presence of certain chemicals. This sensory data is then converted into electrical signals, the language that our robot understands. The sensors are the eyes, ears, and touch of our robot, giving it a sense of the world, a sense of being. Now consider actuators. If sensors are the robot's senses, actuators would be its muscles. Just as our muscles enable us to move and interact with our surroundings, actuators allow our robot to perform physical actions. They convert the electrical signals from the sensors into mechanical energy. Whether it's a simple task like picking up a glass of water or a complex one like dancing to a beat, actuators make it possible. But sensors and actuators can't function in isolation. They need a medium of communication, a way to transmit and receive signals. This is where electronic circuits come into the picture. Acting as the robot's nervous system, these circuits carry signals from sensors to the robot's brain, and from the brain to the actuators. They are the silent wires that connect and coordinate all parts of our robot, ensuring a smooth flow of information. Electronics, therefore, are the lifeblood of our robot, the thread that weaves together the various components into a single cohesive system. They facilitate communication, coordination, and control, turning a heap of metal and plastic into an intelligent, responsive machine. Just as our nervous system helps us sense and react to our surroundings, the electronics in a robot enable it to interact with its environment. Without them, our robot would be nothing more than a lifeless statue, incapable of sensing, thinking, or acting. We have given our robot a skeleton, muscles, and a nervous system, but it still needs a brain. Enter the world of computer systems, the brain of our robot. Just as our brain is the command center of our body, a computer system is the command center of a robot. Its role? To process, decide, and command. Let's break it down. Imagine a robot's computer as a super efficient secretary, meticulously sorting through an endless stream of letters, or in this case, data. These letters are sent by the robot's sensors, the eyes and ears of our mechanical friend. They are constantly feeding the computer with information about the robot's environment, like temperature, light, and distance from objects. Once the computer receives this data, it's time for some high-speed decision-making, much like a chess player contemplating their next move. The computer analyzes the data, compares it with the existing programmed instructions, and determines the best course of action. This is where the heart of computer science beats, the algorithms. These are sets of instructions that guide the computer's decision-making process, much like a recipe guides a chef. Now, having made its decision, the computer sends out commands to the robot's actuators, the muscles of our mechanical entity. Just like how our brain sends signals to our muscles to move our body, the computer instructs the actuators on how to move the robot. Do they need to rotate a motor, extend an arm? The computer's command will dictate the action. It's a constant cycle of receiving, processing, and commanding, all happening in the blink of an eye, faster than you can say mechatronics. So the next time you see a robot navigating a maze or picking up an object, remember it's not just metal and wires, it's a symphony of mechanics, electronics, and computer science. Just like our brain, the computer in a robot is its command center, processing information and making decisions. And that, my friends, is the beauty of mechatronics. Now that we have all the components, let's see how they work together in a symphony of mechatronics. Imagine an orchestra. Each section, the strings, the brass, the woodwinds, and percussion play their unique parts, yet they harmonize to create a beautiful symphony. This is the essence of mechatronics. The mechanics, electronics, and computer science, each with a unique role, harmonize together to create intelligent systems. Mechanics, the bones and muscles of a robot, provide the structure and the ability to move. Just as our muscles contract and relax to enable us to perform various tasks, the mechanical components of a robot enable it to interact with the physical world. Next, we have electronics, the nervous system of our robotic orchestra. This is where the signals are sent and received. Just as our brain sends signals to our muscles to move, the electronics in a robot transmit signals to the mechanical components, instructing them to perform specific tasks. Finally, we have the computer, the brain of the operation. It processes the information, makes decisions, and sends instructions to the rest of the system. Just as our brain interprets sensory information and makes decisions, the computer in a robot processes data from its sensors and decides how to respond. Now, imagine all these components working together. The computer receives data from the sensors, processes it, and decides what the robot should do. It sends instructions to the electronics, which carry the signals to the mechanical components. The mechanics then move as instructed, interacting with the world around them. This is the symphony of mechatronics. It's a harmonious collaboration of different disciplines, each playing its part to create a functional, intelligent system. It's a symphony that brings endless possibilities, from robots that can explore other planets to systems that can revolutionize healthcare. As we conclude our journey today, remember that mechatronics is a symphony of various disciplines, working together to create intelligent systems that can transform our world.